Okay, let's talk about an important calculation. It's called the degree of unsaturation. First of all, what is unsaturation? Before we just get into this equation, what does it mean to be unsaturated? So, you've probably heard about saturated fats, unsaturated fats. Regardless, the idea of unsaturation means removal of hydrogen. Saturation means saturating the compound with hydrogen. So if you look at straight chain hexane, N-hexane, this is an example of a saturated compound. If we start introducing pi bonds like this, we're actually removing hydrogens here. So this would be an unsaturated compound. So let's see what effect that would have. First, let's remove these double bonds here and count up all the hydrogens here. Well, we know that in N-hexane, the molecular formula is defined by Cn, where N refers to the number of carbons, H, 2N plus 2. So hex means 6. So the molecular formula here would be C6, and H2N, that would be 2 times 6 is 12, plus 2 is 14. So we should have 6 carbons and 14 hydrogens. On these terminal methyl groups, we should have 3 hydrogens. And at all secondary carbons here, we don't see any double bonds, so we would have 2 hydrogens at all 4 of these carbons. Now what happens if we introduce a double bond? For example, right here. Well, you know that carbon cannot expand its octet. So instead of having 2 hydrogens on either side of this internal alkene, we would just have 1. And the molecular formula would just be CnH2n. And because we remove 2 hydrogens at these 2 positions, it makes sense that we have 12 hydrogens now. Now it turns out the degree of unsaturation for this compound is 1. We've introduced one unsaturated point between these 2 carbons, one pi bond in other words. So let's try to calculate du for this, according to this formula here. Now to use this, we don't have any halogens represented by X or any nitrogens by N, so those aren't included in this equation. We just have a hydrocarbon. So let's calculate this. So du would equal the following. First, we need to include 2 carbon plus 2, where this C refers to the number of carbons in the compound. So the N value here is 6. We have 6 carbons. We double that to get 12, and then we add 2, so 14. This 14 is a theoretical value that is always at the very beginning of this equation. It's referring to the same exact compound without any pi bonds whatsoever. So 14 refers to the number of hydrogens that would be in N-hexane, not 2-hexene. We subtract the number of halogens. We don't have any here, so we're fine. Now we need to subtract the number of hydrogens that are actually present in the compound, all of these red ones, and we determine that we have 12. And then we divide this value by 2, which gives us 1. So du for this compound is 1. We have 1 point of unsaturation. So now let's try to use this equation and understand how it's derived. Why are we subtracting the number of halogens present in the compound? Why are we adding whatever number of nitrogens are present in the compound? And why aren't the presence of oxygen atoms affecting the degree of unsaturation? Let's first look at an alkyl halide. Let's look at this alkyl bromide. Let's look at a primary amine, also containing 3 carbons. And let's look at propanol. So at face value, it seems like the degree of unsaturation for all 3 of these compounds is 0. Let's prove this with the equation. How do we manipulate this equation such that our quotient here equals 0 for all of them, even though at the first carbon we have different atoms bound to them? So let's start with this. For bromo propane, we start the equation by calculating the number of hydrogens that would be present according to this formula, specifically using the number of carbons present in the compound. We have 3 carbons here, so if we double that, we get 6. If we add 2, we get 8. Now we need to subtract the number of halogens present. We have 1 bromine, so we need to subtract 1. Now we need to subtract the number of hydrogens actually present. On this terminal methyl, we have 3, And at the secondary carbons, we have 2 each. And if we add them up, 3, 2, that's 5, plus 2, that is 7. All we do then is divide by 2 and see what we get. Well, I'm claiming it's 0, but let's see. 8 minus 1 is 7. 7 minus 7 is 0. 0 divided by anything gives you 0. 2n plus 2 would give us 8 for this compound too, because we have 3 carbons. We doubled that to give us 6. We add 2 to give us 8. And we need to subtract the number of hydrogens. It seems like we have more than 7. We have 3 here, and we have 2 at these secondary carbons. That gives us 7. But we also have these 2 hydrogens bound to the amine. So we need to account for these hydrogens as well. So 7 plus 2 gives us 9. Now the issue is we're in negative territory. 8 minus 9 is negative 1. So, in order to get 0 in the numerator, we must add 1. So 8 minus 9 is negative 1. You add 1 to that, divide by 2, you get 0. Now you can probably see the pattern here. If you calculate the degree of unsaturation for propanol, you would get 0 because the equation would look just like the one for the amine, except instead of 9, we would have 8. So if we add these up, we get 7. We add this, we get 8. 8 minus 8 gives us 0. Divide by 2, again, it gives us 0. So basically what we've shown here is how to derive this equation. Whenever you have group 17 atoms like bromine, chlorine, iodine, fluorine, you have to subtract based on how many there are in the compound. You then subtract the number of hydrogens actually present, and you add based on the number of nitrogens present in the compound. Here we add 1, so we just add 1. So now, knowing this equation, let's look at tougher examples.